All right, and now I can't remember if I actually turned it off. It looks like it. All right. Are there any questions?
Oh, for the quiz today, are we taking like 2 different quizzes or 4 and 5 on the same quiz?
4, 5, same quiz. One side is 4, the other side is 5.
Okay.
I kill a lot of trees, but save just a little bit here by doing front.
Oh, no, you're good.
For what? All right, so said box sliding on the floor, so
That's fair.
that's box on floor, and the box, if the box is moving this direction. Now, I don't think I actually said it. Today's free food, tater tots. Don't know if you're a fan, they're there. So I'm going to indicate the direction the box is actually moving by just putting a little velocity vector right there. This is not if part of the force diagram, since that was sort of where your question was going. This is just to say that the box is going that way. I'm not drawing the arrow on the box because I don't want to confuse it with a force diagram. So friction opposes the desired motion. Well, in this case, there's actual motion here. I should throw in the word relative. Desired relative motion, because the box is going to the right relative to the floor. It's not necessarily going to the right relative to some car driving by. It's relative to whatever it's touching. And friction hates that. So when you're drawing friction on the other object, if I'm drawing the picture on the box, I look at it from the floor's point of view. So since this is going, if I'm on the floor watching this thing go by, if I'm watching it go to the right, well, friction's going to act the other way. And then from the box's point of view, the box is sitting still, the floor is going to the left, so friction acts so as that. Since there is no such thing as an absolute reference frame in physics, there's nothing that you can say, hey, this is still. Everything is moving relative to something else. Looking at it from the box point of view and watching the floor move versus having the floor stay still and the box move are equally valid. Just like, am I standing on the earth or am I balancing the earth on my feet? Both are equally valid. I will say, in light of what I just said there are certain reference frames which are a whole lot easier to calculate than others. So Bill, how did I? All right. Other questions from 4? Well, any other questions from 4? More questions from 4? Any questions from 4 or 5? I am hoping that this is meaning that people are just really comfortable with the material, as opposed to, we have a quiz today? All right, they should be on the printer, so I'm gonna go get it. All right, so you have a test coming up on Tuesday on chapters 2 through 5. And we'll start with, are there any questions concerning that? Stephanie or Ariana, one of you.
Does the
Steph-
test have a time limit?
All right, so the way I'm picturing Tuesday happening is that we'll start out with any questions, and based on past history for this group, we could go an hour answering questions, or it could be absolutely none, I don't know. So when questions are done, then doing the test, I sort of pictured that test as the only thing that, once I've answered questions, the test is the only thing that we're doing. So if there are absolutely no questions, then I guess you have 2 hours and 50 minutes. The 110 tests typically are, people typically finish it within the time period. Now, what might happen though is as I'm writing it out, I might go, well, they got 3 hours potentially, so, you know, I'm not gonna take that problem out, we'll just leave it in. So it might end up going longer just from the psychological aspect of how much time you potentially have. But my intent going in is that it takes an hour to do the test. But I'm not stopping you at an hour. Ariana?
Are the formulas gonna be written at the top of the test?
If you look at the old tests, I think I've pretty much just done a cut and paste from previous old tests. So if you look at the old test for the test 1, you'll see what I give you.
Okay, and then also, I forgot. Oh yeah, I remember. Is there gonna be a lot of written answers? Or mainly multiple choice?
Oh, I hated multiple choice as a student,
Okay.
so it tends to be written out.
Why? Why did you hate multiple choice?
Because there's no partial credit,
Oh, true.
and I survived a lot of classes on partial credit.
I think I remember you saying that.
Yeah. So I do give some partial credit on multiple choice if you're showing your work. So,
Where's the practice test at?
supplemental materials, not required.
It's under old
Scroll down to the bottom, I
Oh,
think
I
it says
see.
old tests.
I have 2 questions. One, is there gonna be, do you want us to write at any point Newton's laws, verbatim? Like, not
Oh.
verbatim, I guess, but what?
In the
how it
original
works?
Latin, yes.
Okay.
No.
And then second question.
No, I'm not gonna, I'm assuming that you know Newton's laws, I'm not gonna ask you to regurgitate them.
Okay. And then can we do another one of your big, like, force diagrams, since we know that's gonna be on the test?
Okay?
Can you actually do the one that was on the master set? Do you want
That was,
This one?
With the table?
was that the road
Yeah.
boarding?
No, it's, hold
With
on.
the table and the
tablecloth?
flower,
Oh,
Yeah.
tablecloth,
we did.
the magician.
Do you want a picture of it?
At some point, yes, but let's see how much I can do from memory.
Okay.
If that's not a desperate cry for help from a man who's getting to the point that he's gonna start forgetting a lot of stuff. Something like that?
Yep, that's right. You're counting that as a tablecloth, right? Not the table?
Right, so we got
Okay.
this tablecloth. We have multiple colors, we can handle it. So that's the tablecloth right there.
Then yeah, spot on.
And so on the complex problem, I'm gonna break it up for you so you don't have to decide what is, for what you need to draw forces. For instance, I have the pulley at the top attached to the ceiling, I'm gonna keep it that way, just because I don't want you to worry about the forces between the pulley and the ceiling itself. markers, so hopefully one of these will work well. All right, so we had the ceiling, we had the vase with the flower, we had the tablecloth, we had the table. We had the floor. Then we had the roof, and then person. I believe he's standing there.
Yes.
Good. Okay. We are assuming it's an ideal rope. I don't know if I actually stated that or not. There's some tests where I actually write out that it's an ideal rope and other ones that I don't. But if you got a rope in the problem at this point, it's ideal. Actually, I'm not quite sure in 110 I ever get past the ideal rope. 151 I do, 251. All right, so we have our checklist. Personally, I think weight's the easiest one, so let's start with weight. Unless one of you has one that you think is easier, then just shout out one of them, which force acting on what object in which direction.
Weight's good. Start with weight.
All right,
Weight on the man down to the earth. I'll wait on the table.
all right, let's do it in pairs. I recommend doing it in pairs, unless there's an other. If you got an other, then that sort of is by itself, but otherwise, I think students who don't do it in pairs will more likely to forget one. So where's the other part of that pair?
Up on the man from the ground.
Up on the ground.
Up on the ground.
Yeah. Sorry, I wrote it that funny.
Good, okay. Another purple. Ish. All right. All right, got one pair down.
The weight of the table going down. And then the weight of the floor acting on the table.
Ooh.
I don't know what the wording is.
Let's work on the wording right now.
Okay.
So typically, I have the type of force acting in some direction on the object. So this is the weight of the gravitational force or weight acting down on the table. And the reason why I'm sort of emphasizing that wording there is that tells us how to draw the arrow, because that's the force acting down on the table, so I'm gonna write it down on the table. The other one's gotta be up on something.
So, okay, can I try?
Go for it.
Okay. The gravitational weight of the floor acting up on the table. Walk. Okay, that was wrong, sorry.
Yeah, you could just say weight. I was going for gravitational force as more generic, but weight is fine. I think you did gravitational weight or something like
Yeah, I
that.
did. I wanted to add gravity in it, I don't know.
Yeah, sorry about throwing the extra words in there myself.
So the weight of the floor acting on the table. Is that what you said you wanted?
No, that's what you said before. It's
It's
not the
the-
weight of the floor.
It's the weight of the table,
Yes,
So the weight of the table acting onto the floor,
acting up from the floor.
on the floor.
on the floor. Okay.
So this is the weight acting down on the table. The other one is acting up on the ground.
Can you say that once again?
Yeah, can you say it? Cause
I'm gonna write that out.
like, I know where the arrows go, I don't ever have the words that's
Yeah.
right.
And I understand that, and a bit of this, it's very different between, trying to get the wording right and knowing exactly where you're gonna draw it. But weight of table acting down on the table. So that's the direction I'm gonna draw the arrow. This is the first arrow, the one we have right there. That is where I'm gonna draw it. So I'm gonna draw an arrow down on the table, and I'm gonna label it by that. So there's my label, it's circled, underlined once is the direction of the arrow, and the other one is where I'm drawing it.
But honestly, when you say it like that, it makes me think that you're gonna draw the arrow pointing down onto the table, like it's actually pointing on the table, like, I don't know how to put it.
You mean as in draw, like, kinda like that?
Yeah, that's what I would picture, like, if you was to say that and be like, draw arrow onto the table, I would think, you know, that way.
If you actually drew it right there, so if you drew it like that, I'd be okay with that too.
Okay.
Somewhere this arrow needs to be touching the table, whether it's the head or the tail, whatever it is, it just needs to be clearly, this is the force on the table and not the force on the tablecloth or the force on the floor. Just, if you're gonna do that, don't put it in the middle of it, so go and try to figure out what you meant. Alright, now, all forces require two objects. Now, in my sentence here, I've only written one object, that's the table. What is the other object involved?
The floor.
Or ground, depends on if it's a dirt floor or not, but we've got this planet underneath. So, from the planet, or floor, sort of lumping floor and planet together. So this is the other object involved here. And so when you think about the other force, you flip the direction and change the objects. You don't change the force at all. So the other one is weight of table, because it still needs to be the same type of force, acting up on planet, floor, fine, from the table. This last bit right here, the from the planet, from the table, doesn't tell us anything other than where the other force is. Basically the source of it, and it helps us guide where we're gonna draw the second force. But ultimately, I'm gonna be drawing an arrow up on the planet or floor or whatever structure is holding them up. Putting this more in the chapter 5 vein of wording. The planet pulls down on the table. With a weight of 20 newtons. Obviously, we don't need to detail the actual number here, I'm just throwing it in, putting it in sort of the context of one of the master set problems.
Yes, about that. So with that master set question about the dog and the ramp,
Yes?
I just wanna confirm, is it the dog acting down, pushing down on the ramp, and then it's the planet pulling down on the dog, right? Like that's the order of events?
In that particular case, only force that I talked about in the initial sentence was the ramp pushing up and right on the dog. So the reaction force from Newton's third law
Would be the dog,
is dog pushing down and left on the ramp.
okay.
Yeah, the planet's involved there, but the planet's, sorry.
It's the dog on the ramp and the planet on the dog,
Yeah, but the planet has no part in this particular problem there.
yes.
Because potentially they could be in outer space, and I don't think the first sentence would change at all.
Okay, I see. I was just wondering if that makes sense.
So when I have it set up like this, and I say, hey, what's the reaction force to it, from using Newton's third law? Again, similar to what I was saying over there, think, what are the two objects? Planet and table. What's the direction? And so the other force is you change the objects and switch the direction. Everything else stays the same. So this would then be the table pulls up on the planet. with a weight of 20 newtons. So, as illustrated there. Because the table and the planet are being pulled towards each other. Or some of you need to break the thinking of, oh, the planet's pulling down on the table and you're done. No, the table is pulling on the Earth with just as much force as the Earth is pulling down on the table. I'm pulling up on the Earth right now with over 200 pounds of force. Just by my being here. Now, because the Earth is so massive, it doesn't notice. But it's still there. If I climbed up on the table and jumped down, the Earth would come up towards me. Because I'm applying a force to this large mass and it'll accelerate. And having done the calculations, the planet will move about roughly the size of a nucleus of an atom. That's how much the planet will come up. All right. Other questions right now before we get to the next weight? All right, next one, next pair.
The vase, weight acting down. And then back on the floor, weight acting up.
All right, we got 2 more weight pairs.
Tablecloth. The weight of the tablecloth acting down on the earth.
Acting down on the Earth.
Yes.
So
Oh, sorry, no. Weight of the tablecloth acting up
on
the earth.
that.
Yeah.
That's tablecloth.
And then weight of the earth.
It's still weight of the tablecloth.
Okay, of the tablecloth acting down on the tablecloth.
Yeah. Down is defined